ultra low sulfur diesel will hold 0.1% of its volume of water. What that means is that if you have fuel, this happens to be a sample of local diesel fuel, this fuel will hold 0.1% water dissolved in it. That means you can't see it, it won't be cloudy, any of that, it's just in the fuel. The thing about it is, that doesn't sound like much, but think of it this way. That's 1 gallon in 1,000 gallons of fuel. So if you break that down, that's a quart in 250. So in a lot of over-the-road trucks, they have 250 gallons. You can have a quart of water dissolved in your fuel. The hotter it is, the warmer it is outside temperature-wise, the more water the fuel will hold. The colder it is, the less it can hold. So let's just say you pump fuel out of the ground, and today let's say it's 55 degrees, and you put it in a bus. It sits over the weekend, and during the weekend it goes down to 20. The fuel can hold less water. When it can hold less, it pushes it out into liquid water. So it is very possible to have a bus on Friday with no water in the fuel tank, and on Monday come in and have one with water in the fuel tank that you can see, because it will push it out as it gets colder. So you can have those kind of problems just based on temperature. And the colder it gets, the worse it gets. And when it's warm, the higher the humidity and the higher the temperature, the more water the fuel will pick up. So ultra low sulfur holds 0.1%. Biodiesel holds 1%. It holds 10 times as much water. So you can have, if you think about it, you add 5% biodiesel to your fuel, it has more water in it. Now the whole thing can hold more water than it could. That's important. Biodiesel more readily grows bacteria and fungi. Any diesel fuel will grow it if it has water available, but with biodiesel you can grow more stuff. This here is just a picture. I wanted to show this because a lot of people have asked. This is cooking oil, used fryer oil basically. The next step is we try to get the glycerin out of it. So we filter it and then we get the glycerin out of it. And then we make biodiesel out of it. Interestingly, the processes that we use to make biodiesel out of cooking oil, called transesterification, uses water. So we're actually putting water into that fuel in the process. So you end up typically with fairly high water content. One of the other issues with biodiesel that has become, certain engines have more of a problem than others. There's a Mercedes engine and a couple of Cummins engines that have a big problem with it. When you run an engine, any engine, gas or diesel, a small amount of fuel gets by the rings and gets into the motor oil. The heat from the engine typically will vaporize the fuel, the diesel fuel, and then it gets pulled out by the crankcase ventilation system, which is like a PCV system for diesels. The thing about it is biodiesel doesn't vaporize as easily as regular diesel does. So the biodiesel tends to stay in the oil, and you will actually build up the amount of oil it looks like on your stick. It looks like you'll be a quart over and 2 quarts over. And we see them regularly where it's coming out the dipstick tube. And it's worse in engines that are used in your kind of service, where you have low load, short runs, long